So you want to build an MMO. Well, I like the cut of your jib. So I can help with that. So let's start. Enjoy. This video is an introduction to MMO architecture and design patterns. This is your server client topology. Unless you're doing something with peer-to-peer, some sort of hybrid system, you're going to have a server. You're a consumer of events. You're going to have many clients. Those are the producers of events. On your server, you're going to handle the simulation because you want to be authoritative. So you are going to actually simulate something on a loop and process events on a loop. From the network layer, you're going to broadcast those responses back out to a client, as well as broadcast themselves to many clients, which is an additional duty for the server, unless there is some sort of knowledge between these clients as peer-to-peer connections. The game server's simulation queue is your source of truth for your actual data when everything's instantiated and up and running. So if you have NPCs, monsters, the pathfinding associated with those monsters, projectiles on the map, you're going to have that on your simulation. That way you can, as a server, authoritatively know where something's at, say where something's at, and you have an event tagged for that in this that gets processed, or however it is in your schema, and you move them in the actual simulation. And then from that, it generates an event, which may need to just go right back to the player individually, or maybe it needs to be broadcast to the nearby players, or maybe it needs to be broadcast to every connection on the server. And so that goes back out to that network layer and gets transmitted outbound as an event. For the network events, the reason I have this separate on its own queue, because whenever a client is interacting with the server, not everything is, for example, in the context of inside the simulation, which would be like your game's world, your game's map. For example, if a player's logging in, doing some initial syncs of data, negotiations, things like that, you don't need to communicate a message to this simulation. And so sparing that communication, you can just have many writers, for example, in this network event queue where you can just put messages on, and that can be picked up and transmitted out to the clients. In most cases, the client traffic is going to actually have to be set to the simulation queue. The event basically is going to need to propagate out back through this network queue. For your database, and I am referring to the on-disk database, not the in-memory stores you may use if you have an in-memory database or in-memory key value store. This would actually be the offline database. If you're going to write to that while the game server is running, you're going to want a queue just because you want someplace you can, at the lowest cost, just drop a message and forget about it. And other processes that don't need to access your simulation just to see the memory of that or anything, those can just pick that up and write that to the database whenever it needs to be done. In your game server, tracking the neighbors actively is an important way you can save resources because, first of all, you're already tracking the movements of these entities as they have an event and get updated. Tracking the neighbors, basically from a distance check there on the spot will save you the cost of having to scan for any events. So if a player's roaming, or say you have a script to fire if players are nearby, you don't need to do a scan necessarily if you're tracking the neighbors in a set where you can just check membership or somewhere you can just iterate to basically broadcast to these player IDs. Game server pathfinding is an important point to note just because of the pure cost you can lose here if you don't do this right. If you have 1,000 NPCs and each of them are using A-star pathfinding to aggro a player, then you can easily eat your budget tick right away. For pathfinding, perhaps you want to start from both ends of the path, so that way you can check if a path is impossible, and you can also have a number set to give up and the number of paths it's tried. Instead of using A-star, you could use Ida-star. Instead of using Ida-star, you could just use a dumb aggro pathfinding where you just check the next tile. During these checks and during this pathfinding, what you want to do is make sure this has access to whatever index you're using, if you're using an archery for static objects or spatial hashing for dynamic entities. Managing the player states, meaning if a player has a bank interface open or any other interface open, and managing that state. That way a player can't deposit an item in a bank if they don't have the interface open just because the client's saying they're depositing an item in a bank and they're near a bank, for example, which would be the normal traditional check in a lot of games. The only caveat, if you're blocking a player from doing an action based off of this, if you have a desync state, anything that's just not correct, then you're going to prevent the user from actually doing the action. In some cases, maybe it's preferred to actually just track this, log the event, and maybe you have some sort of automation. If this event's seen too many times, something looks suspicious, then you could take action on it. On an MMO game server's map, which can be very large and have tens of thousands of spawn points for different entities, you don't want to have to just spawn everything at all times if there is just no player in the vicinity to even interact. Maybe you do, maybe that's the style of your game server where everything's just constantly occurring as persistent. And as well, the hybrid where you want it to slow the tick rate of these far away NPCs, just to keep them active and not despawn them so you don't have to respawn them, but to just lower their tick rates, basically variably. Other than lowering the tick rates, you could outright freeze the tick rate for those entities. On your server map, your tile map, your grid map, we're going to have cells with your X and Y position, filling that cell. For your whole grid map, we can break this into chunks. How big you want to make each chunk really comes down to the quantity of players, size of the map, how fast those players move across the map, and the clustering of those players. Since it's just a number, you can always change that later in your system. If our map is going to be mutable, meaning we're going to track states, a door opened, a door closed, and if a new player enters that map, they need to see that the door is open or closed, or if you can destroy entities and spawn new entities, one thing we'll want to do is track chunk versions. And that can just be a simple counter. We increase by 1 every time there's an event. That way, when a player enters that area, he knows that his chunk version is a mismatch. He needs to get up to this chunk version. The actual updates that he's going to receive are going to be coalesced updates. So if he's 200 chunk versions behind, you may not receive 200 updates. If someone was rebuilding the same object on the same position, they would just receive 1 update. When all players are up to a minimum chunk version, you could reduce that counter back down to 0, or every time you restart your map itself, you could reset that down to 0. Chunk subscribers, primarily used for players. That way they can receive backfill from the chunk they exist in or the chunks they're subscribed to that would be a radius of chunks around them. That way, when you cross from one chunk to the next as a player, you don't have to actively receive the flood of updates from that chunk. Looking at how a player builds an object, that communication coming from the client to the server first validating everything and then updating the server simulation, so placing that object inside the simulation, deleting any other object, replacing it, as needed, and raising the chunk version by 1. That event would be broadcast to the neighbors or the chunk subscribers. So you can kind of go either way because you're maintaining an active list. For example, that player who's building this object as an event, you could broadcast to any neighbor of this player because I know those are all within the distance of needing to know this information, or the chunk subscribers themselves could be leveraged. The problem with using a chunk subscriber system there for that is if your player is on the border of this chunk between the next chunk, then you would have to do a radius of chunks at the minimum. Otherwise, you're not going to catch those cases. As players travel the map, they'll become subscribers to different chunks, and they'll drop their subscription to the other chunks they're leaving. As they become subscribers to new chunks, they're going to compare chunk versions, and they're going to need to raise their updates to that chunk version. The server is going to see that and provide them a coalesced backfill of updates. The coalesce means if you build an object on the same tile, we don't need to send 2 different events, for example. You just need 1. Or in the case of several walls being built in a straight line or a box region, we could send the range of the coordinates there as a single update. Another example, the NPC is changing their coordinates, so they're moving, roaming, or chasing a player. The server, this is going to happen directly on the simulation layer, so the simulation is going to update the entity's position in memory, and then it's going to generate an event that's going to get broadcast out to the players on the network. For this, you want to update the neighbors of the actual event here for the NPC. you're actively maintaining their neighbors. You don't want to necessarily do the chunk subscribers for basically the same reasons we provided on the last, but the last one could be viable because you're actually storing that update as a chunk update. When an NPC is moving, obviously we're not updating our chunk version. So we want to make sure we're updating based off of the neighbors of that NPC itself, especially since an NPC could be traveling from one chunk to the other as it moves. From the client perspective, as you receive an update, you want to ask, do we already have this NPC instance basically instantiated? Is this NPC even within our local render distance? Should I just drop the update, or should I keep knowledge of this logically? And if I'm moving myself as a player, if I entered the distance, now I should begin rendering, and maybe that could be stale data. How are we going to handle that? These are thoughts that should be running through your head as you design. Between the server and client, we'll have different kind of values and thresholds for those values we'll want to negotiate or set. The network update distance, a distance between a player and something else where we actually say you can have knowledge of this. So for example, we're not going to tell a player every player on the map around them, but as they approach them, they become neighbors. Well, now we may start transmitting that player's information, or say it's a projectile coming from that player, that same thing as it approaches this distance. Now, as the server, we can say this client is allowed to know about this. That way, you don't have to worry about someone reading memory or anything else like that. The client's local render distance, which is the distance at the point we decide to call something out of view for the client, or when we decide to instantiate something that's predicted to enter the camera view. So basically, it'll be ready by the time we do get there. Really, that doesn't have to have any negotiation with the server, but you might have some values you enforce on a client or attempt to anyways. Even if a player is rendering the full tile map at one time, if they're not receiving those network updates until they get to those distances, they won't have the knowledge to cheat effectively if that was their goal. On the server simulation tick, you'll want to have budget set and time limits alongside those budgets pairing with those. That way, if the NPC processing or the projectile processing, something is taking too long and it's not the most critical portion of your game, you can skip that. Or say, if it is the most critical portion of your game, if you're, a bullet hell vampire survivors and projectiles are the critical point of your game, you'd rather the bullets move than anything else in the game in terms of priority, and then maybe next on that list than the enemies, right? If you would rather that be the case, then you want to set your budgets and time limits per entity types that we're processing in these thresholds on our simulation. On your game server, you could have certain kinds of entities or events be more burst-like and see a rise for a short period of time, perhaps, and it's not normally seen. So it would violate these budgets and time limits. In that case, one easy solution would be multiple queues for a normal queue, a priority queue, and an overflow queue. Obviously, the normal queue being less important events, the priority queue being the projectiles in my example events, and then the overflow would be possibly a normal event that got overflowed, and basically that is now the priority, or at least processed at the same priority level as a priority queue. As well, you can have specific rules for these burst conditions. One condition I could think of is if you had many players entering one chunk, so say you had several hundred players now entering a chunk, you could choose to reduce the movements tick basically to a roguelike movement where you're only updating the actual positions of tiles rather than the movements within those tiles as it crossed between them if there was some sort of mass event or something and you needed to spare your game server updates. You want to block players attempting to speed hack, so you want to rate limit their movement speed, have some logic sanity checking on that. You want to enforce client-side and server-side paired definitions for buffer times. That way, when, say, for example, a client opens or closes a door, like through spamming of an action, but extremely quickly, maybe to denial of service to server, who knows, but faster than you would limit maybe, say, half a second for that action to occur, then you know, one, that they are violating that local constraint of a client that would be behaving normally, so either they're hooking methods or something else out there, and as well from the server's perspective, you're going to send a deny to that request of an action that they sent.